Hi, and welcome back to exercise number 3 for the Android app reverse engineering workshop. So for exercise number 3, our goal is we'll just keep practicing our DEX reverse engineering skills. The more you do it, the more patterns you see, and the easier it gets to continue reverse engineering more complex samples. So unlike in the first two exercises where we were using our reverse engineering skills in order to identify malware, in this exercise, we are going to use those reverse engineering skills to try and find a vulnerability in an Android app. So just showing how these same skills can apply to a different area or reason for information security. So let's get to it. So the context for this exercise is that we will be looking at this sample called photoprovider.apk that is in the virtual machine, and it has this SHA-256 digest. And so the context is that you are performing a security audit on pre-installed apps on a phone. Maybe you want to let these devices onto your enterprise network or something like that. And for this pre-installed application in particular, you are concerned that there may be a vulnerability that allows it to run arbitrary commands. So you want to determine whether or not that's true. So here are some suggested starting points. So if we are concerned that this application allows or has a vulnerability such that other components on the device, whether that be untrusted apps or other code such as a binary or something else that's executing on the device, is able to send commands to this app to be executed, we need to think about what are the entry points to the application where another app could send information or send those commands to be executed. The second step to filter and focus our analysis is, if we're so worried about the command execution, what are the API calls in Android that would allow that to take place? So how do you actually execute a command? And when I say command, I mean sort of like shell or Linux commands from an Android app programmatically. So go ahead, do some searches for API calls, do some searching and understanding of what might be entry points, and pause the video here and give it a try and come back after you've given this a shot. Okay, so hopefully you paused or you're just continuing to run through. So let's talk through how we do this. So first, starting points. What are entry points to this application? And so to filter this down a little further, sorry for the background noise, I've been waiting and waiting, but it keeps going. But what are app components that are being exported? And so for this to look into answer, we need to understand, one, how are app components exported, and two, then take a look at this specific app and see what they are. And so to determine this, we often use the app's manifest to take a look. So here we are in JDEX. Remember to find the app's manifest. We open up Android manifest.xml here in resources, and then we can see the manifest. And so by default, any components within this application are not exported. And the keyword exported, when you look it up in the docs, means that other apps or things that are running on the device can access it. So by default, for example, this service that has no extra indicators, aka com.adapts.photo.syshopper.task that's all it says, only has a name, it is not exported, and therefore another application cannot start the service, stop the service, or things like that. So to understand what that exported means as I continue to look through, let's open up another tab if I can get that. And so exported keyword Android manifest. And so we see there's a couple. Let's just go with service because it's going to be largely the same, but you can check out each of them in the developer docs. And so when we check out, oops, wrong keyword, exported, Android exported. This indicator indicates whether or not components of other applications can invoke the service or interact with it. True if they can, false if not. So the other key thing though is that so any of them that do say exported equals true in here, that means any application can interact with the service or activity or receiver. However, there's one other way that something can be exported. So let's just see here. Here's one. So here we see they've specifically said this exported equals false. Let's see if there's any other ones. False, false. Here's a true. So in this case, this com.dataichannel.dc app service, this service can be started, can be stopped, can be bound to by any other app or code on the device. But just because these others don't necessarily say export equals true, if any of these define an intent filter with any actions in them or other things, that means they're automatically exported, even if it's just a single intent filter. So in this case, this service up here, com.apps.photo.syshopper.sysservice, because it has this one action included, that means it is exported. So any application on the device could send an intent with this action and interact with this service. The same for write command receiver, which has an interesting name, and task receiver. So that's how you know that each of these are exported and whether or not something external to this application could interact or command or whatever with it. So going back to the slides, where were we? Right here. So that's how we figure out what app components are exported. The next step is to figure out what are API calls that can execute commands. And this is another just type of search through documentation. So two of the most common that you'll see used in the Java or the Kotlin code in order to execute shell commands is runtime.exec or the process builder class. If they're going to be executing commands via native code, and we'll get to native code reversing in the second half of this workshop, they would then use the system call in the native code. So go ahead, using this information, go back and try reverse engineering again and come back to me once you've given it a shot, and then we will walk through it all together. Okay, and so if you've given that a shot, now let's reverse this whole thing together. So we've seen some interesting names and some components that are exported in this manifest. Now let's look for where there might be uses of the API calls. So we're going to go to our source code, and I'm also going to go to navigate, text search, and start looking for some of those commands. So the first one might be runtime.exec, and you might need to play around with, what types of search terms you use as you're looking for it. Because in this case, they're saying runtime.getRuntime.exec because object-oriented languages. And we see that here's one place where it's not a hard-coded command. They're executing whatever's in this string variable. So this is a good place in reasoning to start. So let's take a look here. So in this code, we see they immediately, as the second line of this method, they're going to execute whatever is passed to this method in string. So that still looks promising. Let's continue tracking back to see what that might be. Find usage, and there's one place that it's used. So here we are. This is the one place that method was used, and it's passing in the command to open up a bash shell, and then an additional set of commands here in an array list. But when we look at array list here in this method, we see that it is hard-coded, so it's not influenced by any external arguments being received. It is just passing in an array list to ls-l, anything that's here in path/su. And while this is very interesting and should raise some red flags if you're doing security audits for pre-installed apps, it's not the specific thing that we are looking for our context. And I bring this up because, one, it's very easy to find a lot of things depending on when you're reversing that might not be relevant to the exact question you're trying to answer. So this app has a lot of issues and a lot of sketchiness, but it's not the one thing I told you that we were looking for in our context. So we're going to keep moving on to try and answer the question we started out with. And the reason why this is not our arbitrary command execution is because the command that it will execute is not arbitrary. It is hard-coded. It is not being received here from an external entity. It is always just going to run ls-l looking for this SU. So let's keep going back to our search. That was for the runtime.exec, but we have some other API calls that we should keep looking for. So the next one I'm going to give a shot to is process builder, which is another one you can open up the docs, and we see 4 different places that they have a new process builder. And so a couple of these came up. sysservice.a we saw was an exported service when we were walking through the manifest, as well as write command receiver. So write command receiver is an interesting name, which sometimes you might jump to first, but just for the sake of this, I'm going to look at sysservice.a first. And so what we're seeing here is that what you are seeing in JADEX is Smalley code. So what you saw in the first part of the workshop. And so this is happening because JADEX is saying, I don't know how to decompile it back to Java, so I'm going to show you what I can, which is Smalley. And so let's walk through what this is. So the way we read this is, one, you can open up the Smalley data sheet to just follow, but if you've also looked at some assembly, it can be rather intuitive. So what we see is it's saying register 3 equals a new process builder. And then we're going to call the process builder constructor, that's with the init keyword, on R7. R7 here is strings. And when you take a look at the process builder docs, so let's go back to this. Android. We will see that in the constructor that takes a single string command, it will start a new process that will run whatever that string is. So let's get to our constructors in here. So public process builder list string command or process builder string. So constructs a process builder with the specific operating system program and arguments. This is a constructor that sets the process builder's command to a string list containing the same strings as the command array in the same order. So what it's doing, it's creating that new process and is going to run it with whatever's in your commands. So that's what we have happening here, is it's creating the new process builder, and then it has the constructor, and it is going to run whatever commands are here in this string array that were passed as an argument to this method. So let's see where this method is called and where that string array comes from. So we see one place here, and we see it is in this method is we get this string, we print it out, and then it's passed to that method that we just looked at that runs it as that process builder. So let's see where this one is called. We don't see usage. Let's keep scrolling to see what else is going on. So we don't see this called anywhere. That doesn't necessarily mean that's correct, because we do see all of these different types of warnings from JDEX didn't process it right. But this is one of those cases where I will keep looking to see if there's a more obvious answer, and then come back if I'm still not sure. So if we go back, remember we did have another search, another thing to look at here in our search for process builder. So write command receiver was a really interesting name, and why usually in some cases I'd probably open that one up first. But let's start here. So here we see them doing the same thing with process builder. They create the new process builder, set to R3, then run the constructor with whatever these arguments are. So like we did last time, let's also see who calls this method. Find usage. We see there's one place, and it's here in on receive. And so this is a broadcast receiver, com.adapts.photo.syshopper.write command receiver. And so whenever this broadcast receiver receives something, this method is automatically called. And so what it's doing is it's going to get the intent that this receiver received, and it's going to get the action. So there are two options, which is the same and matches as what we saw in the manifest. So if we come back to the manifest here, we saw the write command receiver here, and we talked about how it was exported because it combined two intent filters. And here there are two different actions. So going back to that code, we see that they have they do different things based on which action they receive for the intent. So if the action for the intent that it received is write command receiver, then it does this, recovery system.install package, which is where, and basically you can look up the API, but it is doing the OTA update for the device and installing a new firmware image. But here over, if the intents action matched android.intentAction.adaptsphoto.opper receiver, and the intent has an extra, meaning like an extra package that the sender sent, which is easy to add, then it will get those commands separated by a space and send it to our method A. And remember, method A up here was the one that takes that array of strings, aka what we just received in our intent, and immediately passes them to process builder. So that is how this application can receive an intent sent by any application on the device that includes a string with space-separated commands, and it will execute those commands. But wait, there's more. What makes this especially concerning, and why this might have raised heckles, is that the right word? Or whatever, right? Raised flags for a reason that it ought to be reviewed by either automated systems or yourself, is that one, it's a pre-installed app, and pre-installed apps can, by their nature, have more privileged capabilities than user space applications, because they have to run your operating system, so it makes sense some of them are required to have extra capabilities. But in this case, this app takes it a step further, because here in the manifest it declares Android shared user ID equals system. So system is basically one of the most privileged user IDs on an Android device, like one step down from root. It basically can have access to all permissions, everything that it may need or want to do. And the way that these shared users IDs work in Android applications is that two applications can say, hey, I want to run as this shared user ID and give it a name. And as long as all the applications that are saying, hey, I'm shared user ID X, are signed with the same certificate, then they all run as if they're a superset of each of those applications' permissions, code, etc. And so system is the user ID that is required for a lot of the integral apps and things that make up the Android operating system and make the device work. So when then other applications have also declared user ID system, they have access to that superset of code and permissions, meaning they're super, super privileged. The one protection mechanism is that anything to run as this shared user ID system has to be signed with the same certificate as everything else, which is the operating system. And thus, only things that are signed with the phone's platform certificate or platform key can run as this privileged user ID system, and the platform key is going to usually be whoever the OEM that created or manufacturer of the device's key. So in this case, if we look at this application, we open up its certificate. They did put this in there. So this is running on some sort of MediaTek device, and this key, in order for it to be able to run as system, whatever the key is for the certificate will have to be the same one as the device it's running on. So that's the protection mechanism. But to wrap up what's been a very long and noisy video, thanks to some of the ambient sound. And so to bring it all together, we have an exported receiver, which means it can be interacted with by any app on the device. And that receiver will receive intents that can include commands, which are then directly executed by Process Builder. And the app is running as system UID, and those commands that it's executing through the Process Builder API are being run as this privileged system user ID. And what that would look like is you could, if you have a device with this application on it or a similar one, even just through ADB, you could test this by sending the intent to action we identified along with saying, hey, here's my string extra, the key is command, and here's the list of commands that are the values for that. And so with that, congratulations, you've identified your first vulnerability in an Android app.